I would say that we will do 2 short tests. 2 short tests. That's nice. What? Yep. Here we go. The derivative of the natural log of x. Any idea? Oh, whoa. If you guys want to see the proof of this, okay, if you have a logarithm where the base is not e, then you get 1 over x, so it's the same thing, but you take the natural log of b on the bottom as well. Okay. And those are our rules. So we do have one really cool part. It's our last problem. Hopefully you find as much enjoyment in it as I did. But they're pretty nice. So let's find the derivative of the following. Obviously, a lot of these are going to require the use of what kind of rule? The chain rule. So we set it up. It's the derivative of natural log of u. 1 over u. And then the inside function was 1 over x squared. What is the derivative of x to the negative 2? I reduce 1 over... So you bring the negative 2 in front, negative 2 over x to the negative... I'm sorry, x to the negative third, or over x to the third. So that's our derivative. So now what I have to do is I have to multiply them together, don't I? So if you have 1 over x squared and you plug it in for u right here, instead you're going to get 1 over x squared. What's 1 over x squared? Just x squared times negative 2 over x to the third. What do you get on top? What do you, for x? That's the derivative. Is that kind of neat how that works out? So the natural log completely goes away. You're left with a power function. Works out pretty good. Log base e. Not log of e, log base e. What's the outside function here? No. Log base 4 of u. Very good. Inside is e to the 2x. According to our rule that we just wrote before, what is the derivative of log base 4 of u? Good. 1 over u ln of 4. Now I have the derivative of e to the 2x. Not 2e to the x, but 2e to the... Yep. If you do the chain rule, you'll come up with that. Because the derivative of e to the x is e to the x, so it works out very simple, very plain. I have to put this back in, and I'm going to multiply them together, and I get 1 over e to the 2x, natural log of 4, times 2e to the 2x over 1. What's going to happen? Very good. E to the 2x's will cancel. You're going to get 2 over natural log of 4. That's just a number, isn't it? It's a constant. So if it's a constant, if you have a constant for a derivative, what's the original function then? It's just it's a line. It's a line. Can anybody look at this and tell me why you get a line? Anybody see it at all? If you have a logarithm of something with an exponent, what can you do with that exponent? So you would get 2x times log base 4 of e. Log base 4 of e is just some number, isn't it? Times 2 is just another number. You have just x to the first power. So when you take the derivative, you can see you end up with a constant in the end. So that's why that works out. All right, what rule do we have to use for c? Nope, just the quotient rule. Not even a good attempt. Okay, so let's take the derivative. F prime of x, maybe I should use correct notation for once here. F prime of x is equal to, what's the derivative of the top? 1 over x times the bottom left alone, e to the x, minus, yeah, the derivative of the bottom is e to the x. Isn't that fun? You just, every time you take the derivative e to the x, just makes it feel good. It's just like, oh yay, it's e to the x. Yeah, well, times the natural log of x. Over what? E to the x quantity squared. What is e to the x quantity squared? E to the 2x. What can I factor out of the top? I can factor out e to the x, so I get e to the x times 1 over x minus natural log of x over e to the 2x. What will happen? One of the e to the x's will go away. Can I leave the answer like that? No. You have a fraction over a fraction. This is a complex fraction. So we gotta find what? Common denominators. So we've got 1 over x minus x natural log of x over e to the x over 1. One minus x natural log of x over x times, what's the reciprocal? 1 over e to the x. So your end result is 1 minus x natural log of x over x e to the x. That's your answer. I mean, the calculus isn't bad, is it? I mean, it's just, it's pretty simple. Just all right. Good. U to the 1/2. Liz sees it. What's the inside function? Yep. So we'll have to do the chain rule again. You'll see though that the chain rule for natural logarithms are very simple. What's the derivative of u to the 1/2? Yep, you guys remember that? 1 over 2 roots of u. If I want to do the derivative of natural log of 2x minus 1, you'll get to a point where you can just look at that. The derivative is 2 over x. Okay? Watch how it works out. Watch how it works out. You got natural log of u and 2x minus 1. So if we set that derivative up, what's the derivative of natural log of u? 1 over u. I'm sorry, I'm sorry, I said 2 over x. 2 over 2x minus 1. Sorry about that. And then the derivative of 2x minus 1 is 2. Multiply them, and you get, as we said, 2 over 2x minus 1. So it always just ends up being the derivative of the inside over the inside. It's pretty, just kind of like e to the x, you know, it's derivative of the top, just move it out front, you know, so it's pretty easy. So now we just multiply these together. What's going to happen to the 2's? They go away, and you're left with 1 over the root of natural log of 2x minus 1 times quantity 2x minus 1. That's bad, huh? F prime of x? Yeah, you should say it's the derivative. I'm just getting lazy. I'm running towards the end of the year, too. I told my wife, I said, I'm ready for 4 weeks left of school. I said, I don't know if I'm ready for 6 weeks left of school, and that's where I'm at. So, and I got to come back. You guys remember, when you graduate, I have to come back that Monday. They're bringing all the teachers back for, I think we've got a lot of work to do. I'm sure there's really... All right, here we go. What rule do we have there? Quotient rule. Oh, this one looks bad. All right, quotient rule. F prime of x. What's the derivative of the top? Good. 5 over x. Super important. Does anybody not see why the derivative of that is 5 over x? Derivative of the top is 5 over x. What's the derivative of 3? 0. What's the derivative of natural log? 1 over x times your 5 over x. That's all you got. Okay? Times the bottom left alone. So 4 minus 2 natural log of x. Minus, what's the derivative of the bottom? Negative 2 over x, so plus 2 over x times the top, 5 natural log of x plus 3. All over what? What's it? Yeah. Yeah, you'd be cutting your finger off, yeah. Yep. That's all right. You just said that because you want everybody else to learn, which is great, so thank you. I'm going to just do one little trick here. I'm going to factor out a 1 over x. And I'll be left with, in the top, I have 5 times 4 minus 2 natural log of x plus 2 times 5 natural log of x plus 3 over 4 minus 2 natural log of x quantity squared. So where can I put the x? Just stick it on the bottom. Well, yeah. It's like you were multiplying the top by 1/2. So just divide it by 2. So multiplying the top by 1 over x, you're just dividing by x. That's all that's happening. That's the answer. Well, you can't have a fraction over a fraction. That's totally illegal. Just like you can't have the square root of a number in the denominator. You can have the square root of a variable, but not a number. Oh, yeah. Thank you, Zach. Oh, no, Zach sees that we have like terms here, don't we? I didn't see that. Thank you, Zach. 5 times 4 is 20. Minus 5 times 2 natural log of x is 10 natural log of x. Plus 2 times 5 natural log of x. Oh, isn't that nice? Plus 6 all over that x 4 minus 2 natural log of x quantity squared. So what happens? Negative 10 natural log of x, positive 10 natural log of x. So what number do you get on the top? 26 over x 4 minus 2 natural log of x quantity squared. Very good. So I would have had that problem incorrect because I didn't see that you could combine some like terms in there. I was thinking ahead of the last problem. That's the one I really worked on for today. It's really pretty. Yes. All right. Instead of thinking of f of x equals, let's think of y equals. Okay. So, if you're going to take the derivative of this, do you see what you would have to do? Product rule twice. You'd have to use product rule twice and with the chain rule. So there's a nice way that when you have lots of products or even division, that you can use logarithms to your benefit. Now, one thing that we've learned in algebra is that if you do something to one side, you just have to make sure you do it to the other side. And that holds true if you have an equation sign. We do. We have y equals the square root of x e to the x minus 2x plus 1 to the 20th power. Watch what I can do here. This is really nice. I'm going to take the natural log of both sides. Yep. Oh, what do natural logs allow you to do when you have multiplication? Yeah, pull out the exponent up front and split the multiplication into addition. Maybe. Okay, now let's take Emma's advice. What did Emma say we should do? The exponent's out in front, so we have natural log of y is equal to, when you bring the exponent out in front, you get a 1/2 natural log of x plus x natural log of e. What is the natural log of e? 1, so you just have x. Isn't that nice? Plus 20 natural log of 2x plus 1. Well, look at what you have. Isn't that a lot better to take a derivative of than what you originally had? So the only problem is now the left-hand side. We're not taking the derivative of y. We're taking the derivative of natural log of y. Close. We have to use our implicit differentiation. Remember, when you had something like this, y squared equals 3x, and you took the derivative, you said it's 2y y prime, correct? Very good. So when we use our implicit differentiation, because we don't have just y solved for, we have, as Emma said, 1 over y times y prime equals, what is the derivative of 1/2 natural log of x? 1 over 2x. What's the derivative of x? 1. What's the derivative of 20 natural log of 2x plus 1? Yep, you would use the chain rule. You get 40 over 2x plus 1. Now, if we're finding the derivative, what do we simply have to solve for? y prime. So I would, in order to solve for y prime, I would multiply both sides by y. So I have y prime is equal to y times that quantity, 1 over 2x plus 1 plus 40 over 2x plus 1. And if I have a derivative, it needs to be solved in terms of x. What is y equal to? Yeah, it's that guy right there, right? So now we just write it as a product and you're done. What's that? From the very beginning, we said that we have this function y is equal to that. So when we ended up with a y in the end, we have root of x, e to the x, times, we said quantity 2x plus 1 to the 20th. And we multiply that by 1 over 2x plus 1 plus 40 over 2x plus 1. No, that's done. We're fine. And so the nice thing is that, yes, you very easily could have used the quotient, or I'm sorry, the product rule twice there. However, I want you to understand, it wouldn't have taken much for me to add a couple more onto that, right? I mean, we can multiply by the natural log of x and then, 2 to the x. Well, you can see that the power of natural logarithms allows you to break it up into pieces that are easy to take the derivative of. So who cares how long it looks in the end? The fact is that we could make use of it. So that's it. I know what you guys want more than anything, and that's some homework. I have some. You could go ahead and work on 1 through 12, 39, 40. Whoop, 2 through 12, sorry. Do I have the wrong number, Megan? Yep, 449, 7.4.